So good afternoon, everyone, and welcome to our ICBE Advanced Productivity Skillnet webinar. Today, our presenter is Fiona Fennell from Think for Purpose. By way of introduction to Fiona, Fiona completed a Master's in Quality Systems with the National Centre for Quality Management in UL under Eamon Murphy 20 years ago. Her thesis was on the role of language in team-level innovation, and she conducted her research on site at both Tell Labs and Motorola Semiconductor. Fiona spent the last 6 years performing coaching STEM professionals as individuals and teams. She used the problem-based learning approach in the form of virtual interactive workshops. Teams work together on exercises often tied to real-world tasks and practice their critical, creative, and systems thinking skills. Fiona will give us an insight into 2 of these exercises today, and she will share her 2020 research by her own company, Think for Purpose, on the soft skills most required of STEM professionals. Today's topic is solving complex problems with critical thinking skills. What are the types of problems and work settings arising from Work 4.0 and VUCA? How can we adjust our thinking settings both individually and collectively? And 2 ways we can leverage remote working teams for a critical thinking culture. The ground rules for today: Fiona will present for about 20-25 minutes before opening up the discussion for exploration. For now, everybody is muted. We encourage you to submit questions or comments via the chat function. And where we encounter problems with broadband, please bear with us in case we need to stop the camera. Today's session is being recorded, and without further delay, I will pass you over to Fiona and we will get started.
Thanks a lot, Clodagh, and welcome everybody. I appreciate your time, given that time is in such short supply for us all these days. So we will get cracking. And just to start with a little, I suppose, introduction, and to say that as technology advances, it's actually getting trickier to join the dots, as skills inevitably are becoming more specialized. However, it's also getting more crucial that we do. In order, first of all, to solve complex problems, but for also other reasons that we'll go into. So these dots that I'm talking about, they are the dots between knowledge sets, and also more and more between humans and machines, and most importantly of all, between technical solutions and values in order to maintain quality. So as Clodagh said, I founded Think for Purpose last year to get STEM professionals thinking more about how they think. The what is the challenge of more cross-cutting problems and more overlapping systems. And the good news is that we already have the how if we can combine new technologies with some very old thinking. The why, as I said, is quality, but more specifically risk. This is just getting more abstract. With more automation, it's hidden in algorithms. And with complex manufacturing like biopharma, it's become more intangible. So risk at the level of microorganisms. Critically, the FDA has stressed that risk is inherent in our own thinking, and that subjective decision-making with each of us is likely to, quote, place a different probability on each harm occurring and attribute different severities to each. So this is where Think for Purpose comes in. We all see knowledge and learning as key to solving problems, but so too is something called cognition. This comes from the Latin cogniscent, meaning to conceptualize and to recognize. The FDA are very interested in this subject as it reveals how much we depend on unconscious mental processes to evaluate risk. So too are creators of autonomous vehicles to explain how humans intuitively compute risk so that they can model this for machine learning. So research by Nobel Prize winner Daniel Kahneman has shown that we apply decision rules called heuristics and we use mental shortcuts called biases. These save us mental energy, but they can also give us some oversimplified representations that don't always match reality. So in other words, how we think and learn can cause us problems. Expert intuition can be trusted, but only to a point, and even very experienced specialists struggle to identify that point. So what we need most of all really are critical thinking cultures. So as I said, we use problem-based, or I didn't say it, but it was on my slide, we use problem-based learning in Think for Purpose. There's no point telling people what critical thinking is and where we can go wrong. They have to experience it for themselves to really learn how to adjust their critical thinking habits. So we're going to use one of those exercises now, in fact. So I'm going to take you on to a platform that I use. It is called Miro. And what I do with teams and individuals is bring them onto Miro so that they can actually do exercises in critical thinking. So for example, what I'd like you to do today is an exercise for us where you try and work out what are the top 5 causes that prevent critical thinking. So what are the top 5 villains, do you think, preventing critical thinking? We're going to see how good our collective IQ is, collective IQ being the ability of a group to solve more problems than its individual members. And the good news is it's when we struggle to actually find answers, even if we find the wrong ones, that the subsequent learning is richer. So don't worry about getting these right or wrong as such. It's an exercise that we can do. So I'm going to give us 2 minutes to vote, and each of you obviously has 5 votes. Chloe, did you think I'm okay to start the vote now?
Yeah. So there's a link here in the chat function. So if you go to your chat, click on the link, you have 2 minutes and you have 5 votes. So from this list, Fiona,
yep,
they should, yeah.
I'd like to, I haven't started the vote yet, so your 2 minutes hasn't started yet. I'm giving you a tiny bit of extra time. Okay. Once I start the vote, I want you to click on and press, it'll be a plus sign on each of the post-it notes and pick, you'll have 5 choices. Okay, so pick what you think are the top 5. And we'll revisit this at the end, folks.
Just a minute, Fiona, the link isn't coming up for everyone. So we put it up. So I'm just going to repost it here again.
Okay.
And Fiona, to pick what are the top 5 that are preventing us.
Exactly. Sorry, what are the top 5 obstacles or enemies of critical thinking?
Okay. Everyone in meeting. Okay. Everybody should have the link now. What are the top 5 obstacles in critical thinking? If you click on that link, perfect, brilliant, thank you.
Do you want me to start the vote, Clodagh?
Please do,
okay,
Fiona.
Perfect.
2 minutes and 5 votes each.
That's it.
Going for our collective intelligence. Brilliant, thank you.
Okay. I've never had any team get them all right to date, but I'm always ready
we're
to
going to surprise you today, Fiona.
Exactly.
Just put them back up, Fiona, in case people, or they're looking at them on the board. Is that it?
Sorry.
Okay.
Yeah, that's fine.
Yeah.
I'll keep them there as well.
Link looking for sign in. So do they need to sign in, Fiona?
I know you didn't use a sign in yourself, Clodagh. Now, I suppose what we could do is people could use the chat box as well if they want to vote that way.
Yeah, maybe we'll come back here. So
is that okay?
Yeah. So
and if they just write an abbreviation for each of them.
So type in your top 5 here. If everybody does that, and I'll gather them up, Fiona.
You mind? Yeah, we probably have some from each, so we can aggregate them at the end if we need to.
Yeah, perfect.
We won't panic, as they say. Technology can be a great tool, and sometimes it can let us down. We'll improvise if we need to.
Okay.
So we're just down to the last 10 seconds of the vote for those of you who are on Miro.
Okay. And for anybody who was over on Miro, if you can post your top 5 here, or your top 2 or top 3, and we'll gather them up together at the end.
Yeah, perfect. Thanks, Clodagh.
Thank you.
I'll give you an aggregate for mine towards the end anyway.
Yeah, if we just leave that slide up for a minute as people come back.
Yeah.
Too little and too much data is consistently coming up there.
Okay. Yep, that happens.
Black and white thinking is coming up consistently, too little time.
Okay, that's interesting. I'll hopefully have a few seconds to talk about the data one in particular. So at the end, I have a slide for that. So we'll move on, I think.
Okay.
And the point being that we don't always think about the thinking tools that we use. Okay, maybe not enough. So for example, here, I've given a few examples of lean tools, which are really useful to prompt us to think critically and to ask good questions. However, we don't always think what's the fundamental question that each lean tool is asking. Obviously, it's good from the point, this is a version of the Simon Sinek circle, in case people recognize that I've just added to it. But obviously, from the point of view of who, it is useful to ask who's responsible, who's accountable, who should be consulted and informed on projects, etc. But the catch is that actually engineers, research has proven, aren't always aware of which principles, tools, or heuristics they're using, and tend to apply these fairly automatically. So an example might be, we introduce a clean room to a manufacturing setting. This works on the basis of segregation. But engineers will often apply other TRIZ principles automatically, so sometimes without considering all the implications. An example of that would be a pharma manufacturer standardizing their packaging of prescription drugs for efficiency's sake, but effectively moving more risk and closer to the patient. So we need to pick our thinking tools more deliberately to spot that means end approach and its unintended consequences. In fact, research into an area called naturalistic decision-making shows that professionals in high performance, high risk settings are so fond of particular tools, they forget to stop using them past their utility function. That includes cardiac surgeons, it includes pilots, and it even includes scientists in the field of diagnostics and forensics in particular. So the point is, in a nutshell, we need to grasp the logic behind every tool in order to pick the right ones consistently. We get very fond of our tools. So context is everything and Work 4.0. This is a representation of that in a graph form. Work 4.0, it's more subjective, it's more complex, more abstract, and it's also more novel. So when everything is interrelated, as they say, everything matters, and problems don't come independently of one another, they come as strings, and more work is interdependent. Drawing on interconnecting systems, for example, to provide personalized medicine, medication, and combination med tech products, we need more end user involvement so that they can co-create products with us and self-service. But the paradox is that the more sophisticated and customized a product or service becomes, the more good design and delivery is about what is technically optimum. Is less about what's technically optimum, I should say, and more about what is safe and understandable. So for example, in hospital maintenance rooms, they are full of perfectly good equipment that clinicians assume are broken because how the equipment works is not fit for purpose. In fact, a 70% optimal technical design can be better than a 90% technically optimal one if the missing 30% opportunity cost presents less risk. So the context we are now in means we are in a higher stakes game and even in a one-shot opportunity at times. So it's the thresholds and trade-offs that are the most important choices and decisions we make. So counterintuitively, it's not always the specialists who contribute most, although we do need them for the depth of knowledge, but it's often the generalists who can see the wood for the trees when it comes to risk. So the wider context is VUCA. Our brains are designed really to look for single cause-effect relationships and also to seek single solutions to problems. But COVID actually wasn't the cause of VUCA. The volatility, uncertainty, complexity, and ambiguity were both an input and an output of this complex. Technology is driving volatility, industries are getting disrupted, misinformation is crowding out good science. So we can err on the side of underestimating, but equally overestimating risk. So when I did some research last year, the results here are in the italics, and it wasn't surprising to see that STEM managers were emphasizing an ability to deal with the unexpected as their most desired competency. They also reported a lack of agility to pivot between problems, particularly in grads, but no mystery here, and not the fault of graduates. Their study streams are narrowing more and more. The emphasis is on testing them on subjects independent of one another, both as people, but also the subjects independent of each other. So for VUCA, we need vision, we need understanding, clarity, and agility. Now, I have a separate talk on VUCA that I did last year. It goes into each of these elements in a lot of depth. If you would like that, I can send you on the notes and the recording of that presentation. But again, in a nutshell, what I'm saying is we need independent and also systems thinkers, and we need to encourage both. So here, this could be used as a tool actually when we're faced with novel problems. It's breaking down very simply problem solving into two stages, but it's reminding us of the good questions we need to ask. And culture is really important here because it influences risk perception in particular, and very much so trust. Trust has a major influence on risk perception. We like to take on expert advice, but we don't always consider how relevant that advice is. So for instance, the degree of exposure the expert has to comparable cases or the frequency of that exposure. If we're designing a medtech product, we create a user case narrative, ideally with the user patient involvement. And we need to focus most on what's critical and what's contingent. The choice is often not really between great technical solution A or great technical solution B, but much more between worse and less worse. But involving as many stakeholders as possible gives us the best chance of asking all the right questions and generating the widest range of options. Often it's not ideas we're short of, but it's our own team, however, being too samey in its thinking and too narrow in evaluating these. I'll give you an example of that towards the end. For complex and what we call wicked problems, we need to keep asking these questions while we solve the problem. This is because full information is not available when we start. It actually emerges during the problem solving. So conditionals need to be monitored consistently and constantly. So what do I mean by hard, complex problems? We have actually three types of problems. We have tame, we have hard, and we have wicked. We'll look first at the hard ones. I think the tame ones you can handle without my input. In Industry 4.0, problems just aren't as well defined. So for example, in biopharma, even with thousands of variables well defined beforehand, a single unidentified microorganism can close a manufacturing site if it finds its way into the final product. So to prevent this, we're constantly balancing competing considerations, and we need to justify in advance even the smallest change. We are in what we call feedback-heavy environments. Interrelationships between elements make things a lot more complex. So for example, if we're scaling up a process, even with a lot of good controls in place, the process won't behave the same as each cell culture is in itself a microenvironment. Problems are non-linear. So for the solutions, we need cognitive diversity, pulling from a wide spectrum, not just of knowledge sets, but also ways of knowing. We need people with good expertise for sure, but we also need people from different experiences and educational backgrounds for that one person to ask the one question nobody else thought of. In fact, it's often self-taught people who come up with the unique solutions that specialists overlook. So no wonder then that the founder of Regeneron last year stressed a beginner's mind as the most important quality he was looking for in graduates. And that's less to do with age and a lot more to do with mindset. The key thing is to be willing to challenge assumptions and keep challenging them. So in fact, it's not just complex, but also wicked problems we're dealing with. And this is about environment. So like this surreal chessboard, the boundaries are blurred. So siloed thinking is dangerous. Even in biomanufacturing, safety and commercial value of product depends as much on the utilities as it does on the equipment, and the equipment in turn depends on the cleaning regime that's in place. Therefore, we need to actually assume each product as worst case if we want to be as safe as we possibly can be. And that requires a unique set of systems even, and solutions for each product. So again, a multi-stakeholder approach works if we get a range of perspectives. And it's an interdisciplinary rather than just a multidisciplinary approach that we're looking for. So actually experts are more prone to biases in these wicked environments. Why? Because they focus on very case-specific situational details. But if patterns aren't repeating themselves, then the base rates generated from previous cases are less relevant. The more we expect to see something, the less we see. And I suppose the less we see anything else we're not expecting to see, and the easier it is to be fooled by what we may be superficial similarities. We also pay most attention to the data we get first. This is called an anchoring effect. So we need to involve different people at different stages in the problem solving and present sets of data at different stages to them. And finally, we need all these people to communicate well interprofessionally. Scientists who can talk to and even think more like engineers, and vice versa. And this is why. You see, engineering and scientists each have their own strengths and weaknesses, and we need a combined approach. The basis of science is obviously skepticism, and that is foundational for critical thinking, to encourage us to ask questions and gather evidence. Peer review is also useful, using dialogue like a kind of a critical control function in our thinking. Engineering's great strength is its integrative nature. It gives us a mindset to push beyond experience, while empiricism can only tell us what is or what was. Engineering uses analogies to apply principles that work from elsewhere. So for instance, biomimicry gave us a simple product like Velcro, but a very useful one. Trains are shaped like kingfishers for their aerodynamic qualities. And to solve wicked problems, we also need to travel a bit. In fact, what we need to do is time travel. Sorry, this slide always gets stuck for some reason, and it's a bit slow to come up. So what Think for Purpose does to join the dots between science and engineering is we use philosophy. So don't be surprised, because science began as the philosophy of nature. If we want to interpret well, in particular, which is what ambiguity, really pushes us to do and challenges us on, we need to make accurate predictions based on interpretation, not just extrapolation. So and to do things like convert unknowns to knowns, and even knowns, to unknowns at times, as we're faced with in VUCA. So a lot of the PMBOK and the project management methodology is based around this and includes tools for that particular purpose. Also, from a combination point of view, and why we need philosophy to bring science and engineering together, is even if we look at technology and the meaning of that term, that's a combination of the Greek techne for art and craft. So for integrity of design in medtech, we're going to be making a lot of unlikely combinations and associations. And for example, when we design medtech products, we combine psychology and biomechanics in the form of human factor engineering. So more and more, we're going to need these unlikely associations. In fact, we always did. That's where innovation often comes from. The pacemaker came about by accident. PCR, the testing that we're hearing about at the moment, was also based on what we call the adjacent possible. So the inventor remembering, for example, from his mother's laundry business, how starch hardened into a gel, and that's basically what we have as the basis for PCR. So science can give us empirical evidence, which we need. Engineering can give us contextual relevance, which we also need. But philosophy should help us on the logical coherence, which we really need for clarity, particularly in the face of VUCA. So, as I said, we want to fight systems with systems, I suppose. Science, is useful, particularly from the point of view of inquiry. It helps to meet a burden of proof by using questions to generate examples and case studies, etc. Managers at the moment are bombarded with questions with a lot less time to answer them working remotely. But the tools that Think for Purpose uses are those that, for instance, the All Blacks use, and that's the connection there between Socrates and the All Blacks. We coach people on what's called the Socratic method, and that helps them to ask less questions, but better questions. So it encourages individual responsibility to self-regulate learning. So that's also what the All Blacks use for their continuous improvement of their players. So it's not just doing what we've always done well, even if this was successful, but looking for stretch opportunities by questioning our assumptions and continuing to question them. So this also stops us automatically jumping onto new technologies or methods until we understand the concepts behind them and their limitations. It takes courage because it invites disagreement. But that fits the Maori culture, and it also fits our culture. A devil's advocate approach actually originated in Catholicism. So I'm going to give you a handout today to, I suppose, give you some simple, just 6 types of Socratic questions that you can start to apply immediately within your teams. And an example of each. That's a bit of a technical example at the bottom, but very simple tool, but very powerful tool, particularly when you're facing novel problems. Now, at the bottom right-hand side there, we have a chap called Descartes, and I haven't joined the dots actually between Descartes and systems thinking on teams, because actually Descartes was wrong. It is not, I think, therefore I am, but what we know now from sociology and from neuroscience, it's actually we persuade and therefore we reason. It's our social context and social instinct that gives us our thinking ability. So how we, I suppose, need to disagree and be wrong is particularly interesting. We need to do both and more of it, but we also need to become more confident in that and more united as we do it. So from the Socratic method, I'm going to give you a handout. You can also come back to me for the notes from the VUCA talk. But let me talk for a little bit in terms of how we can actually leverage the situation we're in at the moment to improve systems dynamics on teams so that we can do better divergent and convergent thinking. I mentioned innovation earlier on, and two things we need for innovation is the right balance between effective or emotional conflict, so people willing to disagree with each other, and the right amount of cognitive conflict on a team, so we disagree with ideas. Dialogue is really, really powerful. We've less time in one respect to talk to each other now in person, and the face-to-face contact has been challenged by, I suppose, Zoom fatigue at this point, but we still need rational argumentation. So one of the toughest aspects of working remotely is the fact that it's harder for us to read the room from the point of view of emotions, but we still need to do it to come up with good ideas, particularly in the face of wicked problems. So we need to balance the social relationships with getting these ideas out there. And we can learn to do that if we train teams on what's called the Cantor 4-player model, which I do in Think for Purpose. So we use the fact that we're working remotely actually as a strength. When you're working remotely on Zoom calls, one of the things that you can do, in fact, there's a few, is that you can look and read everybody's face on a room in one glance. If you're in the room with the person and listening within a team setting, you're really only paying attention to the person who's talking at the time. But when you're working remotely, you can do two things. You can see everybody's face at once, like the Brady Bunch on the screen, and you can also take notes. We're slow to doodle, even though it helps our thinking within team settings, because we don't want to appear to be rude. We don't have to worry about that. And what we can doodle is actually the pattern of communication on the team. So that's on the right-hand side of the slide there. When we use conversation acts, we can either open up two lines. We can either open up a line of inquiry, so we bring out what we need to discuss and analyze, or we can open up a line of advocacy where we thrash out our different positions. So in one sense, we're all bystanders in a remote meeting. We can all take that tiny bit of a step back that we can't do when we're in person to observe which line are we opening up on the team. And we can also train the team to spot this dynamic as it's happening and to get them to improve and have as more fluid the conversation on the team. And this really helps their critical thinking. So there are just two ways that we can now use to improve the quality of critical thinking, both individually using our Socratic method, which can be used, together in dialogue as well, but particularly this Cantor 4-player model is what we can use when it comes to our team meetings to make those as productive as possible. It's not a productive meeting when everybody agrees on a course of action, but then over the next week, no one seems to follow up on it, because actually what happened at the remote meeting were people wanting to be seen to agree with each other rather than a real consensus being achieved. So there's just two things that I'm going to leave you with. Here are our answers for our top five, I should say, enemies of critical thinking. And data is the one that people tend to jump to first, okay? Understandably, but actually it's not too much or too little data that is the issue. And I'll give you just a quick support of that here. A lot of us would be fans of NASA, as we should be. It's a great organization. And NASA had a mantra, for years and years, in God we trust, all else bring data. The problem with that is it overlooks the power of expert intuition. And when people had hunches, for example, about the O-rings that were a problem with the Challenger voyage, they didn't feel they could go to their supervisors and be as straight up on that and what their hunches were unless they had data to back it up, which wasn't particularly there as people didn't ask the right question. Well, sorry, the data was there, but because people weren't asking the right question, they didn't spot the data. The other example is our fighter, our plane craft here on the left-hand side. The Allies in the Second World War went to look and see how could they improve the robustness of their aircraft. And what they did was when the aircraft came back, damaged, etc., they would study, deconstruct, reverse engineer and figure out what could be done differently. Any of the modifications they made no difference. And the reason for that being that obviously they were only looking at one set of data, which was the survivorship bias in action. When we just look at survivors, we fail to see, you know, what are the main reasons why the aircraft were going down in the first place. And that's the problem with data. As I said before, we're anchored by the first data that we're exposed to, number one. But secondly, to have the right data sets to make decisions from, we first need to ask the right questions. So that is another tip, I suppose, in terms of facing novel novel problems and wicked problems. So finally, because I know I've run a bit over time, Claudia, apologies. Here is an example of why hasty moral judgment and labeling are two of our main causes of preventing us from critical thinking well. Often we have the right ideas, but we don't look at them in the right way. We frame them based on what did or didn't work before. And the problem with that is that when we are in wicked environments, the environment itself is changing. So just because something didn't work before doesn't mean it won't work this time. And we narrow our frames without even realizing. How often do we go into meetings and we've already decided we're going into a meeting to decide if it's solution A or B we want to consider without fully fleshing out if C, D, or E or F even exist. So these are some of the tips that I would leave you with to encourage you to encourage good critical thinking on your teams. And as I said, the key thing is to encourage people to be willing to be wrong. And I think that's, you know, one of the most important lessons we have now is that we are going to be wrong more often. So we need to get more comfortable with that. We also need to get more comfortable with the fact that we're going to need to challenge each other and our assumptions more often, or we're just not going to be up to the task of solving complex and wicked problems. So guys, thank you for listening and looking forward to hearing any questions that you have in the time that we have left.